fast forward into the Lakehouse, this architecture is similar, but as you can see, we extracted this transaction layer. And this transaction layer isn't necessarily a physical layer. It can be made up of physical components like transaction manager or table services. But in fact, in the world of Lakehouse, in particular with Iceberg and also Hoodie, this is actually implemented as part of the table format itself. And I'll get into what that means in a second. But you can think about this transaction layer as a way for engines who are trying to write data into the Lakehouse format to implement asset transactions in a consistent manner. So if you have two engines trying to write into a single table, how do you handle the conflict resolution between them? This abstraction, this transaction manager allows us to do that in a consistent standard way. Table services is something very similar. Like I said before, if I want to compact my data, which means I want to merge multiple small files into bigger files to get better performance. In a data lake world, I needed to write that custom code in my engine, in my Spark, in my Presto, Trino engines. In the Lakehouse world, there's an abstracted APIs that sort of offers us an interface on how to implement those. Now, those are easy to do. You simply call, compact on the table, and then it's done. Some engine needs to do it behind the scenes. The transaction layer allows you to extract that piece out of the processing engine and put it into a separate system. And you'll see later how that pans out. But for example, Upsolver is a tool that allows you to connect to an Iceberg table, and then we will manage all that table optimizations for you.